Back with some more Lox programming language making in Rust. Yep. Before I start though, I had an idea. Holy shit, my battery's really low. I just realized. When I went to bed, it was at like 60% or higher, and then when I opened it this morning, it was like 20%. So I don't know why it's dropping when it's closed. That's probably not meant to be happening. So I might want to sort that out. But anyway, so the last video on my YouTube channel, like my main channel, is a tutorial for modding a video game, and I was just thinking I'd like to get back on making tutorials and stuff. So I mean, originally I was going to turn this series that I'm doing right now, where I'm making a programming language, into a video on my main channel, where I was going to include me making the calculator in Haskell, then OCaml, and now this in Rust. But to be honest, I should probably just separate the calculator part from this part. So I'll make a video about the calculator for both Haskell and OCaml. I mean, especially because I started recording the Haskell one later, like late into the stages of development. So that one's not really good on its own anyway. And then have another video for this, Lox in Rust. And then potentially, if I go ahead and do the same thing in Zig, then make a video for that as well. Although I'm still questioning whether I will do that. We'll find out, really. So yeah, I'd like to do that, really. But like, rather than like just make it a supercut, you know, or like, you know, where it's like my journey, I would make it like an actual tutorial, and then use myself as evidence of the thing working. So like, it'd be like how to make a calculator, right? And then for this I used OCaml, and then like I'd break down like the 3 stages, the lexer, the parser, and the evaluator, and like I'd explain how I did it and all that stuff. So like it'd be kind of like a wombo combo video where it's me showing my own progress and journey, which is cool to follow, but at the same time it's educational because people who are watching it can also learn how to do it themselves. So I think that'd be pretty cool to do. When will I get around to doing that? Like editing that? I don't know. I need a good video editing software on a good laptop as well. I want to try using Kdenlive on this, but this laptop here has no GPU. It's a ThinkPad. I have my other computer which does have a GPU, but that doesn't, for some reason that doesn't help it. It's like really shit. Maybe like if I just wipe it and like get Linux on it, then maybe it'd be good. But like it's an Asus as well, so I don't know if it'd even be good for Linux. I don't know. Like that laptop, I kind of like need to like kind of repurpose it. I might like wipe it, like truly just wipe it clean, you know, and. Yeah, but to do that, I first need to back up my stuff, and I really need to get like a USB, like a hard drive, external hard drive, so I can put all my files in there. That'd be really important. So, anyway, I'll figure something out eventually. Or, you know, I can also buy a new laptop. That's also on my thing to do, but I don't have the funds, quite frankly, and I need to get a job to raise money. And even then, I don't think I can get a job that will pay enough for me to get a laptop in any reasonable amount of time anyway. Like, if I assume I'm paid, like, let's say £15 an hour, and I work at 9 till 5, like, what, that's 8 hours, 9 times 8, sorry, 15 times 8 is 120, let's say the computer I want is, like, £900, okay, I mean, to be fair, actually, that's only, like, 8 days of work, but, I need to find somewhere that I can work for 8 days, 9 till 5, 8 hours a day, that will pay me £15 per hour, which I don't know if that's too likely, but I gotta try. But anyway, in the meantime, I will keep recording and leaving myself a good potential for future videos by recording stuff like this. So I believe I finished the tokenizer stage, right? I got to the end of this, and I said I would consider these challenges, right? These block comments, that's right. I might do, although part of me is just like I can't be arsed. But let's have a look. So let me open up the project here, and yeah, we have the tokenizer here. So we got our keywords, we got all those stuff, and then we got like all these helpers and stuff. To be honest, I don't love this, like how it is right now, especially like with this tokenizer struct. It just feels really disconnected. Like if I were doing this in C++, I would just make the tokenizer a static class, like so it's like kind of like a singleton basically. I make a singleton for a tokenizer, so that you'd call it either like this or like this, where like you construct it and then call it, right? But in Rust, I don't know if that's a good pattern. I think the main pattern here that people usually do is just define a public function like this in a module. So then I still have tokenize, except the tokenize function isn't part of the class. Instead, I define it like this, and then I do all this stuff instead. So it's not terrible, but like, I don't know, for some reason it just feels a bit weird. But hey, it works. It works, doesn't it? And to be fair, like, it's pretty clean, I'd say. Like, you have all these matches. We're matching on the next chars in some cases, so we support double operators. If we were to do triple operators, I'd probably change the system a bit, because matching on 3 chars at once is probably less efficient. But to be fair, like, you only worry about that if compilation speeds is like really slow and you want to improve it. For now, this is fine. Like I said, like it's pretty clear. I could like separate these into like different functions, like separate this into like a function. But honestly, just having them here is pretty fine, I'd say. Like the logic here isn't so crazy that, nor is it particularly like what's the word? Yeah, like not modular, but like it isn't particularly like there isn't any code duplication here either. So like it's not really worth like modularizing either. So, man, it's fine. Like I could separate it, but I just don't see a point right now. But as it grows, maybe I'll consider that. But it won't grow because this is Lox. So if I were making a different language, then I would probably rewrite it differently. But yeah, it compiles, it works. We ran the test last time, so I'm just going to move on really. So for block comments. It says consider allowing them to nest. So to nest them, what you would do is you'd have a count, right? So each time you encounter one of these, you keep a tracker, basically. So honestly, I might as well do it, right? So let's see. So for the normal comments, it's very simple. You just skip until this new line character. But for this one, a slash followed by a star symbol, it'd be different because we need to advance until we reach a thing. So it'd be quite complex. So we're gonna open this into like its own block. We're gonna say well, really just keep track, right? So, hold on. Yeah, so we'll kind of create another loop, like a second tokenizer in a way, except it's a lot simpler. And we'll just say like let current char next char equal tokenizer dot get current char tokenizer dot get next char. Like this. So now it's shadowing these, which is fine. Shadowing is a cool feature. And then we match. So you say match the current char and the next char. If it is this, again, and it has to be sum, because it could be invalid. If it's another opening brace, then we want to increase some counter. So we'll have a count. So let mutable nest count u32 whatever. Actually U8, because I surely not going to less more than that. Should be 0. And then we say nest count plus equals 1 if it's this. If it's a closing brace, so this followed by the backslash, no, / still, then we say if nest count equals 0. Actually no, first we have to do this, right? So first we do, and yeah, so here we get the scope then. We say if nest count, no, first of all, nest count minus equals 1, right? Then if nest count is equal to 0, then we break the while loop. And that's it, really. And then we just advance. So tokenizer dot advance, I think, is correct. Yeah. In fact, it would have to advance twice because you want to get past this. So I think that works. That's pretty quick, to be fair. So then let's just go ahead and compile this. Cargo run. Got some syntax errors apparently. What's wrong? I expected one of... Is it because I broke this up into a different line? It was the comma. Oh right, because it's not a tuple. Right, okay. Yeah, like, which is better, this, or just doing like just separating them? I think just separating them is better. Like, there's really not much point in having the tuple. In fact, I can just say let chars, let's say, equal tokenizer, so like this thing, this, okay. Why is it selecting the whole fucking... I said select the word. So this and this. And then just match in chars. Because in this case, I don't need to know what the chars are, so that's fine. In fact, do I even need it here? Like, do I ever use current char next char? I don't, do I? So to be honest, I could do the same here then, where I just do... Oh, hold on. Yeah, no, I don't use it. So then, yeah, so I can just do the same, where I just do this. And that should work. But let's cargo run again. Whoopsie, got parentheses apparently. On both of these lines. It's easy to forget. Non-exhaustive patterns, that's right. If there's anything else, then just do nothing. It worked. Yeah, sorry, like, all these warnings throw me off. So let's go up here and just insert a block comment then. I'll do it like here. This is a block comment. Should get ignored. I'll just build first and then run. Dot slash target slash this, yeah. Okay. It seemed to cut our thing short, right? I did this, brace end, and then that's the end of the input. Okay, so that's problematic. I don't know why it's ending early, like that. Like, this should break the while loop, right? Not the entire loop. I mean, alternatively, I can use a flag, but that's not really... Hold on. How does breaking work? How does breaking out of loops, out of nested loops, work in Rust? Because it seems like it's breaking out into the entire loop, which isn't what I want. Okay, so usually it should just break the one inside, right? Damn, you can return a value. No go-tos, no flags. Okay. So this, so this should break this loop then, right? And that's it only breaks the match statement. So let me just double check that. So what's being broken here, or braked? Ooh, I guess braked is actually the word, right? Take a break. He braked. Like if you break your car, like go on the brakes. Would you say you braked or you broke? Just a while loop. Okay, so yeah, so it does then. So what's going on? Is it this, the if? Oh, to be fair, it starts at 1. It should definitely start at sorry, it starts at 0, it should start at run. At 1, Jesus Christ. So let's clear that and try again. No? It's weird. It still doesn't work. Why would it not work? So we start at 1. If we reach another 1, we increase. If we don't, we decrease. Oh, it's because of this matches twice? I'm a bit confused. Okay, let's start by advancing. So tokenizer.advance and 2. We do that first. Okay. Then this is 1 already. If we reach this symbol, we subtract 1 and break. Yep. So I'm really not sure why that isn't working. And this is also being a bit goofy. So let's have it also print line nest count. Hold on. That's weird. It seems like it's never actually reaching this case. Hold on, it's because it's advancing twice each time. That's supposed to be there. That's a mistake. And that's supposed to be here. Yeah, okay. There we go, now it's fixed. Okay, so just remove this debug statement. Yeah, so we got this, or asterisk, yeah, brace start, brace end, then the number literal, 5.34, that works perfectly, cool. So that's working. If I remove the spaces around it, will it still work? testing how if it matches correctly on whites and whatever. Yeah, 5.34, that's correct. Okay, so seems like the white space is also fine. So that's good. And if we do a nested block comment, this is a nested block comment. That seems to work as well. And let's say I forget to open one, then that should lead me to get a compile error. Or not. Now I get a brace end, then block, comment, an asterisk and a slash. Oh right, it's issued as a asterisk and a slash, right. Okay, yeah, so yeah, that works. Cool. Nested block comments, ladies and gentlemen. Likewise, if I just start one without an end, then everything else gets commented out, right? So that's fine. To prove that, if I do this, that should just comment everything else out, as you would expect it to, right? Oops. Okay, looks good. So, yeah, I guess for now we're done, right? Just got a few notes here. Okay, next chapter. So, hold on. Let me just... Oh yeah, it's fine, I'm not covering it. To draw in a word, almost every species of tree has its voice as well as its feature. Okay. In the last chapter, we took the raw source code as a string and transformed it into a slightly higher level representation as series of tokens. The parser we'll write in the next chapter takes those tokens and transforms them yet again into an even richer, more complex representation. Before we can produce that representation, we need to define it. That's the subject of this chapter. Okay. So I was worried about this being one of the most boring chapters in the book. They kept stuffing more fun ideas into it until I went out of room. Okay. Before we do that, let's focus on the main goal. Okay, what is your brain doing when you play the part of a human interpreter? I do 2 times 3 first, so I get 6. Then do 1 plus 6 minus 4. So first I do just left to right. 1 plus 6 is 7, and then minus 4 is 3. Although if I wanted to, and I felt that 6 times minus 4 is easier, then I do that first, and I followed by that, because the order doesn't matter. For a computer, the order really doesn't matter. I'm not sure either or is easier, so it would just do it left to right probably. PEMDAS. For some reason, we always learned it as PEDMAS, even though, because like the order of division and multiplication doesn't matter, I believe. Like 5 times 3 over 2 is equivalent to 5 times 3 over 2. If that makes sense. That being said, no. Well, yeah. There's a caveat where it's like left to right. So like if I have 5 over 2 times 3, then it goes left to right, so 5 over 2 is first, then times 3. You cannot do 5 over 2 times 3. That would give you a different result. 5 over 2 times 3 is equivalent to like 15 over 2. Right? So to that extent, I guess division does happen first, if you were to give it an order. Otherwise you say like it doesn't matter, but like it does matter in that one case, such that PEMDAS is actually wrong. Anyway, you know that multiplication is evaluated before the addition of subtraction. Yeah, so you can use a tree. Okay. So you're using post order traversal. So you go post order is LRN. That means you do the left node, then the right node, and then you evaluate the node itself. So what's this? Is you do 2, 3, and then multiply. I mean, it doesn't really matter because like, what are you evaluating? But yeah, post order. So 2 times 3, then 1 times 1 6 plus, right? Then 6 4 minus. So 6 minus 4. I guess. Now that's post order though. I think you can use. I think you don't have to use post order though, right? Like if you did, let's say pre-order, node left right, then you start here, then go here, then go here, then go here. No, whatever. Starting with a full tree, evaluate the bottom was separate. Okay, I already did that. We need to get more sorry. Give it a tree you can evaluate without making the sweat, right? A tree isn't the only possible representation though. In part 3 we'll generate bytecode that isn't human friendly but cluster machine. Oh. But like, the bytecode still evaluates to a tree, no? Or maybe not. I don't know. We need to get more precise about what the grammar is then. Like lexical grammars in the last chapter, there's a long ton of theory around syntactic grammars. Okay. We start by moving up one level up the Chomsky hierarchy. Is that the that graph he showed? Never mind. Regular, context-free, context-sensitive, recursively enumerable. So, context-free grammars. In the last chapter, the formalism we used for defining the lexical grammar, the rules that for our characters get script tokens, we called it regular language. That was fine for our scanner, which was 5 sequential tokens, but they aren't powerful enough to handle expressions which can nest arbitrarily deeply. A bigger hammer. A formal grammar takes a set of separate pieces, calls its alphabet. Okay. Then it defines a usually infinite set of strings that are in the grammar. Each string is a sequence of letters in the alphabet. I'm using all those quotes because the terms get a little confusing as you move from lexical to syntactic grammars. Right. In this grammar we're talking about now, we're a different level. Where now each letter in the alphabet is an entire token, and a string is a sequence of tokens, an entire expression. Right, a sequence of tokens. The alphabet is okay. 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 A formal grammar's job is to specify which strings are valid and which aren't. If we were defining a grammar for English sentences, eggs are tasty for breakfast would be in the grammar, but tasty breakfast for our eggs would probably not. Yeah, probably not. Okay. So we create a set of rules. Rules are called productions because they produce strings in the grammar. Okay. So each production has a head, its name, and a body. There are unrestricted grammars. So unrestricted grammars allow a sequence of symbols in the head as well as in the body. Heads have to be a single symbol for context-free grammars. I don't understand. A terminal is a letter from the grammar's alphabet. You can think of it like a literal value. Terminals are individual lexemes. Okay. I could write this down in my notes, but I don't really think it's that relevant to remember. These are called terminals in the sense of an endpoint because they don't lead to any further moves in the game. A non-terminal is a name reference to another rule in the grammar. It means play that rule and insert whatever it produces here. In this way, the grammar composes. There's one last refinement. You may have multiple rules with the same name. When you reach a non-terminal with that name, you're allowed to pick any rules for it, whichever floats your boat. to make this concrete, we need a way to write down these production rules. People have been trying to crystallize grammar all the way back to Panini's Ashtadhyayi. I've heard about Panini, or however you pronounce it. I assume these are not how you would expect them to be, which codified Sanskrit grammar a mere couple of thousand years ago. Which is why people think Sanskrit is a really good programming language, but I already made a video about that. Yes, we need to define our syntax to use for the rules to define our syntax. Should we specify that meta syntax too? What notation do we use for it? Its languages all the way down. Not much progress happened until John Bacchus, the Bacchus-Naur, and company did a notation for specifying Algol 58 and came up with Bacchus-Naur form, BNF. Since then, nearly everyone uses some flavor of BNF, tweaks to their own tastes. I tried to come up with something clean. Each rule is a name, followed by an arrow, followed by a sequence of symbols, and finally ending with a semicolon. Terminals are quoted strings, and non-terminals are lowercase words. Using that, here's a grammar for breakfast menus. I've seen Bacchus-Naur thingy. I can't remember if it looks like this though. So protein with breakfast on the side, where these are like variables, right? So these are non-terminals and these are terminals. I guess they're called non-terminals because they are not terminating. They are recursive, whereas terminals here are like they don't go any further. So like I could have a protein with a breakfast on the side. So if I wanted to, then I could have, let's say, crispiness, really, or really crispiness. So I could have like really, 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 really crispy bacon with really, really, really crispy sausage with toast with English muffin. Well, no. It'd be like sorry, really, really, really crispy bacon with toast on the sides with no, not toast on the side. Whatever. Anyway, we can use this grammar to generate random breakfast. Let's play around and see how it works. By age of convention, the game starts with the first rule. Okay. Recursion in the grammar is a good sign. It's context free instead of regular. Imagine we recursively expanded the breakfast rule here several times. Bacon with bacon with bacon with bacon. In order to complete the string correctly, we need to add an equal number of on the side bits to the end. We could keep picking the first production for breakfast over and over again, yielding all manner of breakfasts like bacon with sausage, with scrambled eggs with bacon. We won't though. We'll just pick bread. Okay. Okay, so breakfast. Protein with breakfast on the side. Protein expands to cooked eggs, which expands to poached eggs. Or just poached, rather, sorry. With is just with. It's terminal. Breakfast expands to bread, which expands to English muffin. In this case, we get poached eggs with English muffin on the side. So the pipe symbol is for a series. So toast or biscuits or English muffin. Parentheses are for grouping. So I have scrambled or poached or fried eggs. Okay, so really, really, and then you can repeat it 0 more times, right? So really, 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 really. Interesting. I do wonder, is there not a symbol for just like, okay, yeah, there's a plus. So a plus is 1 or more times. A star is 0 more times. Okay, so I will take notes on this because this is quite relevant, and I've already covered it in my uni course. I finished it. I'm done with that. So this is chapter 5, right? Chapter 5. Whoops. Let's click this. Representing code. Enhancing our notation under context-free grammars. Okay. So Baknar, that's how you spell it, is it? Bakisnar form. BNF is a way to express a language's grammar through a precise syntax. Right, there's some rules. So a pipe means or. So if I have bread with toast or biscuits or an English muffin, is there a thing for this actually? BNF? There is. Pretty cool. Parentheses can be used to group. Group what? Okay, just for grouping. So like, yeah, protein, scrambled, or poached, or fried eggs. So apparently Scheme does this. And Scheme is just like, isn't Scheme just like a Lisp thing? I guess so. It says Scheme doesn't have loops. Postfix, a postfix asterisk means repeated 0 or more times per 10. It's like crispiness. Really, asterisk. And likewise, a postfix plus means repeated 1 or more times, or similarly, rather. Crispiness, really plus. Postfix is for an optional production. The thing before it can appear 0 or 1 time, but not more. Okay. A postfix. Sorry, the glare is really making me struggle to see my screen properly. That's better. A postfix, boom, means optional. So 0 or 1 time. Like a breakfast with protein. And then optionally with breakfast on the side. Okay, so now I get this instead. Protein either with biscuit on the side or just bread. So I can have. Oh, never mind. So I can have this or bread. So I could just have toast, or I could have really, 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 really crispy bacon with scrambled eggs with bread on the side, I think. Not too bad, I hope. If you're used to grep using regular expressions in your text editor, most of the punctuation should be familiar. So grep uses this punctuation, does it? Good to know. Also regex, I guess, uses similar notation. Most of the punctuation should be familiar. The main difference is that symbols here represent entire tokens, not single characters. We'll use this notation throughout the rest of the book to precisely describe Lox's grammar. As you work on programming languages, you'll find that context-free grammars using this EBNF or some other notation. Okay, hold on. Extended Bacchus-Naur form. Is that also another thing? EBNF. Oh, it is. Okay. It doesn't seem to like my little arrows. Does it insist I use these arrows? No, use equal sign is fine. Also, this one uses commas to separate things, which is also how I learned it. This one seems to be incorrect, but okay. And does it even use parentheses or just square brackets? No, an option uses square brackets. Yeah, so this is just plain wrong. It's awesome. So it is just BNF. So there is also extended Bacchus-Naur form EBNF, which uses different yet similar syntax. Okay. Okay. So a grammar for Lox expressions. So we're going to start with a subset, okay? So literals, unary expressions, binary expressions, and parentheses. So no statements. Okay. I mean, I've already done this for my calculator though. Using our handy dandy new notation, here's a grammar for those. So there are literals. So expression is a literal or a unary or a binary or a grouping. A grouping is just an expression like this, I guess. Okay. Number. A number, string, true, false, nil. Number and string aren't defined here. Unary expression, binary is expression, operator or expression. Sorry, expression followed by an operator followed by an expression. I have seen this before in a book. Any of these operators. If you're so inclined, try using this grammar to generate a few expressions like we did with the breakfast grammar before. Yeah, so this is invalid. Anything wrong? I can, yeah, actually. So for example, I could do, if I wanted to, I believe there's nothing stopping me from doing a binary expression. So then I could just choose an expression with a literal, so I'll choose true. Then I can do like plus, and then another expression, I can choose a string. So I could do true plus hello. That would be invalid. Okay. Syntax trees. Finally, we get to implement some code. That literal expression grammar is our skeleton. Right, so if it's recursive, we get a tree, an AST. So in a parse tree, every single grammar production becomes a node in the tree. An AST aligns productions that aren't needed by later phases. Okay, our scanner used a single token class to represent all kinds of lexemes. And a token type enum, that's correct. Syntax trees are not so homogeneous. Unary expressions have a single operand, binary of 2, literals of none. Tokens aren't entirely homogeneous either. Tokens for literals store the value, but other kinds of lexemes don't need that state. Yeah. So he sees scanners that use different classes for literals and other kinds of lexemes. If we look at mine, I do indeed use other enums for the keywords. I could also for the identifiers, but I don't. But notice how these obviously store data. If you were to implement this in language like Java or C++, then these would have to be separate classes because they store data, whereas these are just enums, right? So Rust makes it very easy, but in other languages you may struggle. Something like this. I avoid abbreviations in my code because they trip up a reader who doesn't know what they stand for. But in compiles I've looked at, expression and statement are so ubiquitous that I may as well start getting you used to them now. Cool. So we got expression class, which is abstract, and it contains a static class called binary, which extends expression. What the fuck? Huh? Is this like a recursive class? I guess it is. There's no need for this. But is extending expression from within the class? That's which is really funky. How does that even work? Okay, I don't know. Distorted objects. You'll note that, much like the token class, there aren't any methods here. It's a dumb structure, nicely typed. This feels strange in an object-oriented language like Java. Shouldn't the class do stuff? Hold on, so this is the expression for binary expression. Okay, so I guess we'll go ahead and create this now then. So we'll create a new file called the parser, and the parser will, I'll save and hook it first of all. We'll have a enum again, so just derive, debug, that's alright. Derive in braces. And then have our pub enum expression. Could call it just expr, but I don't see a reason to. So we have an expression, and it can either be a what? A literal, unary, binary, or grouping. Okay. I take it the point of a grouping though. It's just parentheses, right? I think those could be ignored, if I'm not mistaken. But anyway, whoops. Okay. Can I close this, please? How did I just open my fucking history like that and press anything? Probably a shortcut of sorts. Sorry. It's a literal. So a literal. Or a unary expression, which contains either that or that. So unary operator, or followed by another expression. And then binary is an expression, a binary operator, and then another expression. However, some people also represent it as a binary operator and then two expressions, which I will do this time. In my calculator I didn't, but this is probably how you should do it. Because then it's like, well, for my if I'm going to do like an order, what if I have a postfix unary operator, like a factorial sign, right? How do I do that? Well, this just makes it clear. By the way, this syntax has kind of grown on me from OCaml, but commas are fine, of course. So then we also need to have the other stuff. So that's our expression. A literal will either be a string literal, or just a string. It's getting a string. It could be a number, which is S64, or it could be true, false, and nil. Now I could do like a boolean, which honestly isn't a bad idea. I'll just do a boolean because like it's supported by the language, right? In the same way that I'm doing a number in a string. I don't know why I make those strings per se. Okay. Then we have our unary operators. So like minus and not. and we have our binary operators. So like equals, not equals. So I said minus, it should be negative. Now we're like giving them their proper names, right? Less than or equals, greater than or equals, plus, minus, times, divide. Five plus 2, 5 minus 2, 5 times 2, 5 divide 2. You could say, oh, to be consistent, it should be divided by, but like it doesn't matter too much, right? Okay. Let me just turn my lights on real quick, unless the sun's gone down enough. It's fine. The problem is that these tree classes aren't owned by any single domain. Should they have methods for parsing, since that's where the trees are created, or interpreting, since that's where they're consumed? This is like an OOP debate right now. Trees span the border between the territories, which means they're really owned by neither. In fact, these types exist to enable the parser and interpreter to communicate. That lends itself to types, so to simply data with no associated behavior. This style is very natural in functional languages like let's say ML, where all data is separate from behavior, but it feels odd in Java. FP aficionados right now are jumping up to claim C. OOP is a bad fit. I won't go that far. You'll recall that the scanner itself was admirably suited to object orientation. Okay. I guess I'll see what that means really as I go on. Metaprogramming the trees. Java can express behaviorless classes called structs. God, Java sucks, but I wouldn't say that is particularly great at it. 11 lines of code to stuff 3 fields in an object is pretty tedious. And when we're all done, we're going to have 21 of these classes. I don't want to waste your time. Really, what is the essence of each subclass? A name and a list of type fields. That's it. Let's automate. Picture you doing an awkward robot dance when you read that. Automate. Is this the fun stuff that he was talking about? Cramming into the chapter. Instead of tediously handwriting each class definition, we hack together a script that does it for us. It's a description of each tree type, its name and fields. What? That's crazy. You know a language is fucked when you need like a fucking code generator, which now, by the way, is just AI to like make this shit for you. Inspired by Jim Huguenin, creator of Jython and Iron Python. Okay, this script is a tiny Java command line app that generates a file named expression.java. Well, I ain't doing this. Oh, yeah, package. Okay. Crazy how I can just fucking do this in Rust and like we're done. I'm supposed to skip all this stuff. I don't really know what to do. Just boilerplate. Right, working with trees. Bro, poor man's pattern matching. Or by poor man, I just mean fucking zero pattern matching. No pattern matching? Yeah, give each class their own methods. That's not, it's not how you do it in OOP. It scales poorly. If you added instance methods to the expression classes, it would smush a bunch of different domains together. Okay. I like how like a large chunk of this is literally just Java sucks. Interpret, resolve, analyze. Rows are types and columns operations. So these are the classes then, with these three functions. Is that literally not what he just said? Imagine if we want to add a new operation. That means cracking open each of those classes and adding a method to it. I don't see why that's a problem. Yeah, I don't see why that is a problem. Like, yeah, like it's tedious, but like that's the interface. It needs to comply to it anyway. Pattern matching. Yeah, but if you want to add a new type, you have to update every single pattern match, which is why I think just having an interface where each thing has their own methods is completely valid. Or if you want, you know, the best solution is multiple inheritance for multiple interfaces. You have an interpretable, a resolvable, and analyzable interface, and then you only derive what you want. Like, it's a fucking no-brainer. But for some reason, languages like Java, well, like C# at least, and I guess Java, I assume Java only lets you inherit from one class. It's fucking stupid. Like, in C++, you can derive from as many as you want, which is like the only time that I would use inheritance, which is for interfaces like that. And even then I haven't, because I just haven't had a need to. Type traits are a lot nicer. I mean, it's funny because like type traits are basically the same concept, just in I guess like a cleaner way. ML, short for meta language, was created by Robin Milner and friends, and forms one of the main branches in the great programming language family tree. SML, Camel, OCaml, Haskell, and F#. Scala, Rust, and Swift bear a strong resemblance. Well, Rust mentioned. Much like Lisp, it's one of those languages that is so full of good ideas that we are still rediscovering them over 40 years later. Yeah. Awesome stuff, really. An OO language wants you to orient your code along the rows of types. Again, this isn't really a problem if you just had multiple inheritance. A bunch of smart language like this, like not only is Java problematic because like Java isn't bad because OOP is bad. Java just does OOP badly, right? In C++, it's more flexible. In Rust, you know, type traits are technically a form of OOP. Having structs is a form of OOP. Like, it supports objects, but like it's not object-oriented language. Like, it's a language that supports objects, and it does it well. Whereas Java tries to force you to use objects for everything, and then somehow limits the object-oriented like flexibility, so that it's actually a pretty bad OOP language anyway. Which is just like, it's just so stupid, dude. Like, the issue isn't with object-oriented programming. The issue is with how how you implement it. Each style has certain grain to it. That's what blah blah blah. Okay. Okay, so I just read this. A bunch of smart language nerds noticed that neither style made it easy to add both rows and columns. Again, it's not true. It's not true. You literally can. But whatever. Turning some lights on. They call this difficulty the expression problem, also known as the Java sucks problem. They first ran into it when they were trying to figure out the best way to model expression syntax tree nodes in a compiler. It sucks too, because I'm trying to use C# for Unity, and because I don't have multiple inheritance, I can't fucking define like interfaces the way I want to. And it's a problem. It is a problem. If I want to add like a new character, like a new like entity, a new enemy to my game, then like I have this issue with fucking not being able to have like proper abstract, virtual, whatever. It's annoying. It's really, really, really annoying. I might be wrong. I think you can derive from multiple interfaces in C#, but you can't like have abstract classes. Can you? Does C# allow deriving multiple interfaces? It does. Yeah, so you cannot have multiple inheritance with normal classes, but you can with interfaces, and that's where it's really useful. So I do like that. The downside is you can't inherit multiple variables from different classes, because I believe interfaces can only have functions, right? Which is unfortunate in some cases. Like if you want to have health in this and health in that, but like honestly, it's still fine. But Java, man, does Java? But it can. So like, what's the issue? I don't understand, bro. I don't understand. Okay. Languages with multi-methods like Common Lisp, C, Lost, Dylan, and Julia. People have thrown all sorts of language features, design patterns, and tricks, but no perfect language has finished it off yet. It's just not true. And like with Rust type traits, it's like having multiple interface inheritance. Like it's the same. It's literally the same thing, honestly. Like it is literally the exact same thing. There's no difference. The only real difference is how you write it, I guess. But otherwise, like a trait is just an interface, and you can derive multiple traits in the same way you can derive from multiple interfaces. Like it's literally the same concept, just written in a different way. And like I guess traits might also allow you to have like, well no, because like traits are types as well. In a way, like, and the same way that interfaces are also user-defined types. So I don't. It's the same shit. It's the same shit. Literally the same shit. Except I'm really like trying to think like what is the exception. I can't think of anything right now. The visitor pattern is the most widely misunderstood pattern in all design patterns, which is really saying something when you look at the software architecture. Yep, it also kind of sucks to write in C++, but hey, it exists. Please tell me we're not going to use a visitor pattern. I mean, you kind of have to, right? In Java or whatever. Whereas in Rust, you just pattern match. No visitor pattern needed. In fact, pattern matching is so good that C++ is literally on track to add it in C++ 29. It's just taking a long time because that language has so much technical debt that it takes a long time to implement new features. Pastry, pronounced beignet. Beignet. And a croule, extending pastry. A beignet with equal emphasis on both syllables. Beignet is a deep fried pastry in the same family as donuts. When the French colonized North America in the 1700s, they brought beignets with them. How are you American spelling donut like that? My preferred way to consume them is fresh out of the fryer at Café du Monde, piled high in powdered sugar, and washed out with a cup of café au lait, while I watch tourists staggering around trying to shake off their hangover from the previous night's revelry. Does he live in France? Well, no, it's in the US, sorry. Must be able to define new patient operations, cooking them, eating them, decorating them, etc. Okay, we define a separate interface. Okay, I like where this is going. Never mind. Fuck. Ooh. Ooh. Bro, what is this? Visit beignet. We're hard coding it? Both of these methods are confusingly named visit, and they rely on overloading to distinguish them. Right. Oh my god, did I hate this so much. This leads some readers to think that the correct visit method is chosen at runtime, but this is the case. Overloading is statically dispatched at compile time. Do people not know that? Seriously? Using distinct names for each method makes the dispatch more obvious, and also shows how to apply this patch in languages that don't support overloading. Like Rust, right? I have no issue with overloading like this. In fact, fucking Rust supports overloading just through type trace instead. Fun fact. Like, if I do string from, like, I believe there are different things that it could be converted from, and those are genuinely overloaded. So the fact that Rust in general doesn't support overloading to me just seems a bit bizarre, considering you can literally do it through other means. But anyway, given some pastry, how do you do the correct method on the visitor page and its type? Polymorphism to the rescue! Bro, Java programmers creating like the most fucking complex shit and then calling them patterns, even though you should never use them ever. To perform an operation on a page tree, we call it accept method and pass in the visitor for this operation you want to execute. Okay, I don't even know why I'm reading this. In each table, each page tree class is a row. If you look at the ultimate messages first, they form a column. So we're using indirection. I love indirection in my code. I love it when I have to use indirection because the language itself is too shit. But it's not, because it supports multiple interfaces, bro. Accept, sick. Visits for expressions. Okay. Let's move it into our expression classes. Oh, cool. We're using the fucking code generator still. Jesus Christ. You know, for how much this book is recommended, and like, you know, obviously I'm following it, I'm glad it exists, but like, why is it recommended so much when it's telling you to use Java with a fucking code generation and like the visitor pattern? Like, it just seems very outdated. I think it's high time someone makes an updated tutorial, because like, Jesus Christ. Another common environment is an additional context parameter that is passed to the visit methods and sent back through as a parameter accept. This isn't mine, right? This is someone else's. I have to see how they did their fucking parser. Cause like, no shot they like did everything that he said. Seems okay. Seems reasonable. There are a lot of methods here. Block, class, expression, function, if, print. You really don't need to. Well, maybe you. Okay, whatever. Ba-ba-bam. Okay, a not very pretty printer. In Rust, this is just given to you for free. Awesome, right? Okay. So binary, parenthesize this. Okay, this is like for writing, right? Yeah, I guess. Literal expressions are easy. They convert the value to a string with a little check to handle Java's null, standing for Lox is nil. Okay. I just realized this isn't even like the fucking parsing stage yet. This is just like setting up Java. You can go ahead and delete this method. You'll need it. Okay, great. I refuse. The visitor pattern lets you emanate the functional style in an object-oriented language. Divides a complementary pattern for a functional language. It should let you bundle all of the operations on one type together and let you define new types easily. Just individual traits, but like that's not what he has here, is it? So, in reverse, in RPN, the operands to a thing are both placed before the operator. So 1 plus 2 becomes 1 2 plus. Yeah, why do we do reverse pulse rotation? What's wrong with just like normal pulse notation? Because like this is 1 2 plus 4 3 minus times. But how about you just have times plus 1 2 minus 4 3? Actually, I see it now. Nesting. 1 2 plus. Evaluate that, then evaluate that, and then multiply it. Yeah, fair enough. So should I change my order then to match reverse pulse rotation? So instead I have the expression and then a unary operator. I might as well. Alright, now for actual parsing. Which knows how grammar, which knows how to control even kings. Parse comes to English from the Old French parse for part of speech. It means to take a text and map. Actually, if it's Old French, it probably just parse. We use it here because in the same sense, except that our language is a little more modern than Old French. Okay, the first major milestone. The Cooper Real Parse, Real Parser is a rare, impressive skill. So, like many rites of passage, you'll probably find it looks a little smaller, a little less daunting when it's behind you than when it looms ahead. It's easier than you think, partially because we front-loaded a lot of the hard work in the last chapter. When I did it in OCaml and Haskell, I did it recursively for my calculator. I do wonder if there's a non-recursive way to do it instead, because that I would prefer, but maybe not. You know your way around a formal grammar. Also, the issue with the recursive way to do it is that you need to like manually define like the levels, and if you want to add like a new layer to your recursive parsing, it's quite complicated and easy to like fucking mess up. So you need to know your way around a formal grammar. Okay, some CS textbooks make a big deal out of parsers. In the 60s, computer scientists, tired of programming in simple language, yeah, they weren't very machine friendly, which is interesting. I really thought that like the oldest programming languages would be like really machine friendly and really suck for humans. Well, I guess like assembly, right? But somehow we got Fortran and Algol, which are both actually quite, like, surprisingly abstract, is what I would say. Imagine how harrowing assembly programming on those old machines must have been, but they considered Fortran to be an improvement. What? Don't diss my boy. My boy, who I've never learned formally, but I have seen. Look at that. Look at that. Bro, this language has reals. Like, do you know how cool that is? Just saying. These pioneers designed languages that they honestly weren't even sure how to write compilers for, and then did groundbreaking work inventing parsing and compiling techniques that could handle these new big languages on those old tiny machines. That's the cool thing. That's why you just start at the highest abstraction layer and then figure out how to implement it. Because then we get to like a futuristic language. You know, it's why these old functional programming concepts are now being rediscovered and focused on, really, because people are realizing, hold on, these are quite useful actually. Classic compiler books read like Fawning hagiographies of these heroes and their tools. Okay. A little self-congratulations well deserved. Okay, can we just start? In the last chapter, I said you could play a XV grammar like a game in order to generate strings. Parsers play that game in reverse. Given a string as user tokens, we map those tokens to terminals in the grammar to figure out which rules could have generated that string. Okay. Once you have the string, who cares how you got it? When parsing, ambiguity means the parser may misunderstand the user's code. As we parse, we aren't just determining if the string is valid Lox code, we're also tracking which rules match which parts of it so that we know what part of the language each token belongs to. Okay. Yeah, so you could do 6 divided by 3 and then minus 1, or you could do 6 divided by, and then you'd have 3 minus 1. Yeah, okay. I mean, this is just precedence, right? So we need to define a precedence for this kind of thing. Yeah. So precedence determines which operator is evaluated first. They tell us that we evaluate the divide before the minus. Operators with higher precedence are evaluated before operators with lower precedence. Equivalently, yeah, I've done this already in my calculator. While not common these days, some languages specify that certain pairs of operators have no relative precedence. That makes it a syntax error to mix those operators in an expression without using explicit grouping. Interesting. So, if, for example, some languages would force you to use parentheses in this situation. Likewise, some operators are non-associative. That means it's an error to use that operator more than once in a sequence. For example, Perl's range operator is an associative, so A.B is okay, but this is an error. Interesting. So you can't do like 1 plus 2 plus 3. You have to group it in parentheses. Obviously not very human friendly, but I guess I suppose it makes parsing easier. Is this yeah, that's an image. I was wondering if this might be like a HTML rendered thing. Is it hand drawn? Yeah, it does look quite hand drawn because these are different each time it's drawn. How do you get such perfect boxes? I have to wonder. It's a nice art style. Sorry. Associativity determines which operator is evaluated first in a series of the same operator. Right, so if an operator is associative, I believe it means that it doesn't matter, right? Or something like that. When an operator is left associative, operators on the left evaluate before those on the right. Since minus is left associative, this expression is equivalent to this. Yeah, like plus is, its associativity doesn't matter. Or something like that. Assignment is right associative, so this is equivalent to this. Okay. So equality is left associative. Equality doesn't matter, does it? 5 equals 3 equals 2. That doesn't matter. 5 does not equals 3, which equals 2. So what we get true, false. But if I said 5 does not equals... Hold on. If I have 5 equals 3 equals 2, this doesn't matter. But if I have this, it doesn't matter now. So if I have 5 is equals 3, that's true. So true equals... What? You can't even change these, I just realized. But say like I did equals true instead then. So I get 5, so I get false, sorry, I get true equals true. Whereas if I did it this way, it wouldn't work. Okay, I guess. Comparison, left, term, left. Plus really shouldn't matter though. But we can just choose one, right? Right now, the grammar stuffs all expression types into a single expression rule. Okay. Sorry. God, I'm so tired. I mean, I've been up the last few nights, but like, I am sleeping. I hate the body, bro. I hate the human body. Human body sucks, bro. Why is it gonna be so tired all the time? Why is it so hard to just like be awake, dude? How much time in your life is wasted by just being tired or sleeping? Like, it's genuinely infuriating. Some parser generator, like, you know how sleeping like flushes out toxins in your brain and like all that kind of stuff? Can we not like just like make like a drug that just like does that to you while you're awake? You know, like the same way that like you wash your hair. Like, can we not just like invent something that just like washes your brain? You know, please. That'd be so OP. Each rule here only matches expressions as its precedence level or higher. For example, unary matches a unary expression like negated. Bro, it's been like an hour and a half and I still haven't actually started writing the parser. This rule never terminates. So, or primary. Okay. So these are the rules for our precedence levels. But you don't need to, right? I really don't understand this. Why we're doing this? Like, this already satisfies that I can have not, like, I can have a unary operator. Or rather, I can have, okay, I can have an expression unary with a unary operator not, right? With another expression, which can also be an expression unary with a, say, let's say like, I don't know, a literal boolean true, and then just a unary operator not, right? I don't understand. I don't know where this is going, but let's keep reading. Awesome. Awesome. Associativity matters in computer science. To be fair, technically a plus operation can matter with associativity because of overflow. I won't elaborate. So basically we define this like recursive thing that goes down, 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 right? So an expression is an equality. Obviously it isn't, but sure, it's an equality where equality is a comparison potentially with these, and then that's a term with potentially these, which is a factor with these, and unary with these potentially, then that's a unary. Or just a primary, where primary is just this. Yep, that works. Okay. So how do we do it then? LLK, LR1, Luller. Recursive descent. They are fast, robust, and can support sophisticated error handling. Man, I said I didn't want to do recursive, but okay, fine. So then how do these work, I wonder? GCC uses recursive descent apparently. As does Roslyn. So top-down parser. So what actually are these then? Like what's an early parser? There was a bug in the old one that made it slower. Okay, I don't know. It's called recursive descent because it works down the grammar confusingly. We also use direction metaphorically for high enough precedence. You reach the lowest precedence expressions first because they may in turn contain sub-expressions of higher precedence. Yeah, that's what I've done for my calculator. Bro, this thing, which direction a stack grows, it grows downwards in memory, but like, I remember in my exam, 1 or 2 of the questions were like about the top of the stack, and like I just didn't know whether it meant the top or the top of the stack. Like I assumed top meant like top, which is what I ended up going with, but it was confusing because like, anyway, terminal, non-terminal. Okay. So it's terminal, then just gives you a token. If it's non-terminal, it's calls a function, an if or switch statement, while or for loop, obviously, an if statement. Okay. Like these, whatever. Right, here's our parser. Takes a list of tokens. So for us, we do pub parse, which takes a list of tokens, So just an array of token, and returns either an abstract syntax tree, which is an expression, or an error. So parser error. Right? Sorry, pub fn. Vec of token meta. My bad. It takes a vec. Well, no, it would take a slice, wouldn't it? Of that vector, but token meta still. Or just move it, to be fair. But like, what if you want to keep track of the tokens? Then you can clone. Yeah, that's fine then. Up to you. So I take a vec. If you want to move it, you can move it. Otherwise, don't move it. And then I'll call it a parse error to be consistent. And that is the function. Then we need to include this thing. So mod tokenizer. This now just is mod parser. And would you like let AST equals parser parse tokens. And we're moving it, so we're not going to borrow it. That's fine. Print line AST with pretty formatting. Alright. Okay, so we just have a sequence of functions that call other functions lower down. Now, in my calculator, I just use names like level 0, level this, whatever. Or like layer 0. No, it was like, yeah, like level 0, level 1, level 2, depending on the precedence. Because it got a bit confusing to like give them explicit names, because they could be different things. The issue with this method is that if I want to insert something between these two, I need to update this, first of all, to return something else. But also, it's highly possible for lower precedence stuff to call higher precedence functions, and that can be quite annoying. Anyway, so this is the rule. We say while match this then the previous previous comparison. So yeah, so first we call comparison, which is this, right? Yeah. When that's done, we say if it is one of these two, because that's what match does, then previous, I guess, gets the one we just parsed or whatever. What? Is previous this? I guess so. And the right is this. And then we have a binary expression. So let's go ahead and do this then. I'll use the same names obviously as the guide. So first we have expression. Well, I don't need expression because I have parse, so we'll just return equality. Where parse equality is a private function and returns a expression or parse error and then we say expression expr equals comparison, so parse comparison question mark, so we propagate the error if there is one, and then we say while hold on, I need to pass the tokens, don't I? Actually, not really. I'll just use a function. So I'll have a struct parser which contains these functions. Impl. Struct parser has a vec of token meta, which is our tokens, and yeah, just move it. So parser let parser equal parser taking tokens, just move it, and then we just do parser.parse equality. Yep. So while I need a way to like match the tokens, right? Or I consume the tokens somehow. How do I do that again? I could like remove them from the vector. Yeah, so it'd be while. Why is it even a while loop? Because it matches. I don't really understand what's going on here. We've already tokenized, right? So why are we matching here? Are we tokenizing and parsing at the same time in this case? But we already have our tokens. We also would best avoid creating multiple lists. I'm stumped. Well, tokens, whatever. So clearly we need some kind of tracker, right? We need to know what position this is, which token we're currently on. So like, okay, well, let me just do this. So we need to do some kind of tokens dot get current token. And then we'll do this. We'll also do this. We'll do loop or match on the current token. If it is a token, do I say import here? Huh? I need to like mod tokenizer. Like, do I want to like use tokenizer like that or something? I don't know. But yeah, so tokenizer, maybe not, I don't know. But tokenizer token if it's double equals, right? Yeah, double equals or bang equals. So if it's double equals, then sorry, this while is just really throwing me off. We only return one expression, right? Right, it uses the previous. Okay, so that's our expression. So we say expression. I just realized we let. Fuck, it's actually so backwards. Expression. It's mutable. And let's just say like this. Operator equals binary operator equals the right hand side equals comparison, so parse comparison again. Which is an expression. And then expression is going to be reassigned as a binary It's an expression binary with two expressions, so left and right? So itself, the right hand side, and then the operator. Okay. Similarly, if we have bang equals, then we have not equals, right? That's it. And if we have anything else, then we break. So anything else equals break. And then we just return the expression at the end, which we just do like this. I hate it, but the compiler will literally yell at me if I don't do that. In fact, it'd be okay expression. No errors yet. Just how it goes. Alright, so now that means I need to have a get current token. Which returns just a token meta. It's really weird. So what this should do, get current token should like increase this. Like in my calculator, what I did was I just basically handed this like the right hand side of what I haven't parsed yet. So like unparsed basically. The unparsed data would go here. But we're not doing that here. We're not passing on data in this case. In this case, we're storing state somehow. So let's have a position, which is a usize. And we'll say, just return tokens at pos. Okay. And then our starting pos will be 0, of course. Okay. And to test this really quick, because I do want to. So why is this not valid? The compiler will tell me later, I guess. So let's say I do parse comparison, which again results expression or parse error. I'll just have it return something very simple. It'll just be a tokenizer token. Sorry, not that. It'll be an expression. That's really just a literal nil. It is a shame I can't do like literal : nil. Is it a shame? I don't know. Anyway. Yeah, so that should be enough for it to work. once I get through these compile errors. So first things first, self.tokens and self.position. Self on this as well. And here. File not found from module tokenizer. I didn't save. Line 36. Expected identifier found 0. Alright. So weird that you have to this language that doesn't support named arguments, but it forces you to use named function parameters. Like, I do like that it forces you to use named function parameters. Sorry, struct parameters, but I wish it was the same for functions. Yeah, I don't need that. Whoops. Did I use an equal sign? I did. Jesus Christ. Couldn't find the module tokenizer. I see. So should I be using tokenizer? Or is it just public? Nope. Right, so I have to do create, that's right. So create tokenizer and just use everything inside it. How did I misspell that? Parse error doesn't exist. Just do it right now. Pub enum parse error empty. Okay, so I don't actually need to use the tokenizer then. Prefix. What's wrong? Found module self, line 50. Why would I not use self? Self value is a keyword. Alright, I have to pass it. So I think it's just like this. It's unused in this case, but whoops. Operator equals line 58. Right. It's enum. Recursive without indirection. Line 4. Yeah, you need to use a box. So like a heap allocate or something. Goofy like that. I forget the exact reason, but Okay. Now just implement these for all of them, or derive them rather. This has type tokenizer. Oh yeah. What do I store meta again? I actually can't remember. The line number. I guess for like errors. Right? So here I'll just return this dot token. Yeah. $54. The type is now wrong. Arguments to this enum variable incorrect. 64. It wants a box expression. How do I do that? Genuinely. Like box from? Box new. Oh yeah. Line 8. No, this is for main. A parser parse tokens. Expected this, found this. Dot unwrap. Well, no. If right, so for this, I think there's a pattern I can use. The rust if let else. Yeah, which is like this. So let's okay tokens equals this. Else, and I'm aware this is very messy, but else. Okay, first I'm going to like let input equal this. Okay, then tokenize input, else, print line, error, or parse error. Really, it should then like have a way to convert them to strings. I haven't really defined that yet, have I? Here, token error is a struct. Okay. So is there a way to convert to a string? Does Rust have a trait for converting types to strings? Sick. Right, let's do that. Stop it. Let's do that then. So implement format display. What? Okay, then implement format display for token error. Is the same for enums. Yes. So implement also format display for token error type. Put up here. The function is called format, takes a self, f mutable f, which is a mutable reference to formatter of static whatever the fuck lifetime, returns a format results. Okay, and it is exhaustive, so we just do match self. And then token error type, unexpected character, C. The macro is called write. Okay, so write into F. Yeah. Unexpected character, boom. That is C. Right, that's it. And then for this one, string, unterminated string, sorry. Unterminated string, stir, and put that in quotation marks. And then just, I'll do this as well actually. Okay, then here, same thing, format, self. Is there a toString? Hold on. It's just format, right? Yeah. So same thing, same formatter and everything. Could copy it, but I want to get used to typing it out. For result, and then just match on self. If it's a token error, actually there's no match here, is there? Right. Instead, I just return write directly to the formatter. Error on line boom. Then I'll do /n/t for a tab with that, and it would just be the line number and the error. Okay, and then can I remove debug from both of these then? I assume no, but display should work there. Okay, so then go back home here, Print line parse error. Boom boom. But the error is a vector, right? If I'm not mistaken. Yeah, it's a vector token errors. So OK tokens, else for actually I do like this. Parse error. Parse error online, whatever. Just print line this. Print line what? Print line the, well, for error in how do I get like the variables? Count stir. Is it like else? Like let? No. Else error? Like this? How do I access the error in a let else statement? You can't. Oh yeah, you just let, well, you know, because then you don't get the error. So annoying. I still think C3 does this the best way. But anyway, so I can't do that. Sorry, I have to do this instead. I have to do let tokens. So yeah, so a bit like this. And then I'll do if let error equals tokens, then free error in errors print line error. With an extra thing at the end. And return. Right? Yep, I don't know why this is blue. I thought my enums were orange, no? No, they are blue. Okay. So if that's error as equals tokens. Yeah, what the fuck? So what theme is this using? Because my theme used to match this, but I guess I changed it somehow. What's ePrint line? Error print line. Okay. Yeah, looks good. Likewise. Well, parser would actually be simpler. I'll just ignore that for now. But we can unwrap safely here. We have to do let tokens equals tokens.unwrap. I think you can see why I don't particularly love this. Other option is, of course, let tokens equals match. If it's an error, do that. If it's okay, just v errors is this. Okay, build. Can I find modular create FMT? Use standard FMT. Cannot find line number in this scope. 87 should be self.line number and self.error. Match arms have incompatible types. In main, line 10. Right, one returns, one doesn't. This is fine here though. This should work because it returns. Oh wait. Then return. That's fixed it. Tokenizer. No, here. Cannot move out of index of vec tokenizer. Tokenizer token, which is not implemented to the copy trait. Why do I need to copy anything? I don't understand. This could potentially fail. But I shouldn't. Cannot move. Hold on, what? Variable does not need to be mutable. Tokenizer 159. Correct. Also correct. Okay. Over here. 54. Can I move out of index of vec tokenizer token meta? You could clone this value. Why would I clone it? Oh, because it's trying to move token. I guess. Okay. So I just dot clone. Dot copy. Tokens in enum. I'm very confused. Why do I need to like explicitly make enum clonable? Okay. What should I do in this situation? Oh, I see. So derive clone or derive copy if token contains only copy types, which makes it implicitly copyable. Implicitly copyable. Or borrow it. Yeah, I'll just borrow it. Okay. That's fine. So with the return type, yeah, return type have to be a token reference instead. And does that work? That works. I hate these unused errors, bro. What do you mean it's never used? What do you mean? Like, what do you mean it's never used? Oh, I guess because it's... Yeah, whatever. Anyway, so let's just cargo run, see what happens. I get a literal nil. So that seems to work, I guess. I mean, like, what is it actually parsing? I just realized it's parsing my tokens, right? So let me just try to like dig an error here. If I do 5 dot dot, no, that's valid actually. So let me just change these. So something, a token error would be like foo bar %sign. It actually doesn't care. That's crazy. How do I get like an actual token error? Okay, yeah, parse error on line 0, unterminated string foobar. So that worked. I don't know why that isn't an invalid symbol though. But okay. I suppose it works, that's fine. So let's say foobar equals boobar. And run it. Print tokens /n, then /n again. Print ast /n /n again. So also this should be okay. Hold on. Let's match on this. Okay, v, just v. Error, just one error in this case. Just return for now. Okay. So yeah, for some reason it's just a literal nil. It doesn't do anything else. When really it should keep on consuming the tokens. So if I think I know why. After it consumes a token in the loop, it then needs to increase usize, so self.pause equals this. Like it needs to consume the token. Hell, fuck. Needs to be a mutable self. Actually, I'm wondering. Okay, fuck off. If this is mutable, do functions that call this one also need to have a mutable self? That is what I am wondering. But anyway, I do. So where is it? Here. Let's mutable parser, because we're gonna change it later. Okay. So still nothing here, which is a bit strange. Maybe here as well, self.pause plus equals 1. Okay, we're now out of bounds. Make a phone call. Hold on. Hello? Yeah. Yeah? Were we? I don't know. Oof. Right. um. Hmm. Hmm. Uh. Yeah. 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 When it's overbooking it. Okay. How does he have no clothes? Okay. Well, message me when he does come back, because I need to think about it. Yeah. Oh. Well, I need to think about it. Yeah, that's right. See ya. Okay. Boom. No. Okay, how the fuck did I even... Boom. Thank you. I mean, I don't know what I expected. Why is it... Oh, man. Okay, I'm very confused right now. We have a list of tokens, I mean, we have the current token. So, like, what is match doing? I assume it's matching on the token. Does he, like, define it somewhere else? He does. Okay. This is so annoying. Like, define the functions first. For token type in types, if check type advanced, return true, return false. I see what he's doing. Okay. Advanced. Yeah, so advanced just increases it by 1, right? Plus plus. Previous get current minus 1. Yes, my logic seems to be correct somehow. But it's like, then how, why is it not working? Why is it going out of bounds? So let me change this to consume token. And it will self.pos plus equals 1. And then return this. So let token equal self.token self.pos .token, and then return that at the end. CSS of like having to do like this -1 thing, just do it like this instead, and make sure it's immutable self. So we consume token instead, which will auto advance it. Okay. So we still get nil though, which is weird. It should keep going, right? I consume the token. No, it does this. So the expression parse comparison. So this just returns nil. Then, like, the literal nil. Just like as an example, a placeholder. So we get our thing here. Then we match self by consuming the token. And it breaks immediately. Okay, I see what's wrong here. So if you look at my input, foobar equals foobar. The token, well, it's here, literally, right? The identifiers are foobar, a double equals, and then you can't see it, but there's a boobar rather, down there. Now, what parse comparison should do is actually parse. So that's an issue. So that to be fair is an issue there. So we'll just do self dot parse comparison here. Sorry, no. Self dot consume token first of all. You know, like as if you were actually consuming one. We'll just discard the output and replace it with null. Okay? So that should work. Except you get it out of bounds. Alright, I have a loop. But the loop breaks. So that should be fine. Really. Actually, no, it's all fine. I see what's wrong. So make these sum. If it's none, that means that we've reached the end of the output and we just break. So consume token has to return an option reference. Oh my days. And I can actually use a fucking reference in an option, unlike C++, which is nice. At least I assume I can. And yeah, returns some token. But if pause is greater than or equal to tokens dot size dot length, I think it's length not size, we'll find out, then return none. Otherwise this stuff, it is size or len. It's len. Okay, shoot me. Cool. So we get a binary expression of a nil, nil, and equals. Okay, we are so back. Awesome. And then we just keep going and expand this. Hold on, I need to consider right now. Do I pay £62 to go to Ireland? Actually, let me just ask my parents for their advice. A question. My friends are going to Ireland tomorrow and I'm invited, but it'll cost £62. I'm debating whether this is a good financial decision. To be fair though, actually I think so, and it'll be even more motivation, and it'll contribute to motivation for a job. Okay, I'm saying yes then. Okay. Right, so let me continue this then. So he's using some like match thing, some goofy don't need all that. Parsing A equals B equals C equals D equals E for create a new binary expression. Right, so if I were to do this with this, so equals 2 bar equals U bar, and let's throw in a not equals there for shits and giggles. We get a binary expression of a binary expression, nil equals, with nil equals, and then not equals. Awesome. So it works. Cool. It is recursive still, so not quite what I wanted, but it is clean. Holy voice crack. It is clean. It is clean. So I can't be too unhappy. The nesting here is a bit fucked, but like, what am I gonna do? Like fucking match equality as like a function? No, it's fine. Okay. Also like the box pointers. I need to get used to this. I don't fully remember why we do this anyway. A box pointer. Like, why not just... Why can't I have a recursive with values? I'm not really thinking right now. Why do I need box pointers for recursive enums? I see. So it just helps the size calculation. Oh, okay, I understand. So it's actually for just the compiler to know the size. Because if it's recursive, then it could like, well, it doesn't know the size. It needs static sizes, basically. That's why. I see. And like in C++, you need pointers. Yep. A box is just an owning pointer with no overhead beyond the pointer itself. Okay. Is a box pointer always heap allocated? Yes. Okay. Is this problematic? Because, you know, stack allocation is preferable. It's a necessity. Fair enough then. Okay, so we got these box pointers. Alright. So then for comparison, we just do the same thing, right? I'm aware I'm skipping through this, but it doesn't really matter. You can see how this, like, that does its shit, I guess. So for the next one, let me just look at these rules here. So we get a comparison term followed by another term. So we're going to need to have a function parse term. In fact, what I'll do here is duplicate this function. Its body will now be for parse term. Yep. And here we're going to change the input. So we have let mute expression equals self.parse term. And then at the end we'll return the expression. And above that we have a loop which matches on self.consume token. So if we have some token greater or equals to, right? Actually, I don't know what the tokens are called. I need to remind myself. Greater equals, less equals. Okay. So it's only 4, right? Yeah. So if it's greater, then let the operator be binary operator greater than. And the right hand side will be an expression from self.parse term. And then we just say expression updates to be expression, a binary expression with a box pointer for expression and a box pointer for right hand side, and then the operator. Now you're probably thinking, could I condense this into something else, into like a modular function? The answer is yes, potentially. I may come back to that later, depending. And likewise, same thing actually, just for the other ones. So greater, greater, greater. This would be greater equals. So greater than or equals. We'll have less than, and then less than or equals. Okay, cool. So now if we go here and do this instead, whoops, empty case should be break. Okay, it's just nil here. Why is it nil? Try the simple case first. That works. But I can't do equals. Like, can I do like 5 equals this, and then that should recursively go down? No, I just get nil for some reason. Why might that be? It sees 5, a token, consumes it. That's weird. Does this work? It shouldn't. Right, so that actually just ignores this side completely. This is never recursively actually parsed? That's weird. Okay, so now we have another issue to debug. I'm really not sure what's going on here. So we start here. We parse comparison first. When we parse comparison here, we get this. That's fine. Then we move on, and we parse comparison again. When we parse comparison, we get this. Then it breaks, and it should go back to the caller. Then we consume token. If double equals, then the right hand side we parse comparison again, which is this side, which should just give us a nil. but instead it's ignored completely, which is really strange. Print line. Expression. Yeah. So it's like this just doesn't ever happen. This loop just immediately breaks, which is weird. Print line. Self dot tokens, self dot pause dot token. Boobar. Okay, so the next token here is boobar. So somehow we're skipping this. We're skipping the equal sign completely after we go through this. Because this consumes it. If it finds nothing, then it should backtrack. Okay, I see the issue now. Oh shit. Hold on, guys. Little deviation for a second. Because something just dropped. Any second now. The premiere for the C++ documentary.
The software over there. How does it talk to the other one? What protocols do you...
Holy moly. I'm gonna watch this later. Oh, what the fuck? The Primogen learned Odin. Yeah, this is going straight to my watch later. That sounds like... I mean that like sincerely. I'm gonna watch it later. Okay, yeah, so I see what the issue is. Is there an elegant solution to this? I mean, I could just backtrack, right? Or I can peek the token and then only consume it here. Yeah, I'm gonna do that instead. I don't like the idea of backtracking. So self.consume token. It means that it will no longer return anything. But that's fine, I think. Oh, but it needs to do it like here. Or put it here. Okay. So this is the plan. Consume seems like I'm gonna return it though, so I'll change it to advance token. Okay. So advance token peak. Actually, peak would work the same, wouldn't it? It would still return an optional, so that's fine. It's just advance Literally the only difference is this is void, and it's just this line. That's it. Which means this is no longer mutable. And yeah, okay. Advance. No longer need to do this either. I saw I had it like this just like before, but okay. Okay, now it works. So you see we get greater than, and then we get it equals afterwards. And if I reverse this order, it doesn't work if I reverse the order though. But what if I do this? That works. For some reason though, it doesn't work if I do equals. Why might that be? I'm so sorry, guys. You can't see my fucking AST output because I'm literally covering it with my camera, but yeah, it's not correct. So I can tell you that much. So sorry. What might the issue be? If the loop breaks, this never triggers, so that should be fine. So now what's happening? Now it is the wrong fucking script. Now it is doing this. No, yes. So first it's parsing comparison. Right. And then from that, so let me just change this order here. Okay. So first we're parsing comparison, which in turn parses term. So that just says 5. Then it peaks. It doesn't find a sign it wants, so it breaks the loop. And then just returns nil. That's what should happen. Okay, yeah, and it does happen. So if you... Okay, let me try this. So that's my AC right now. So you can see that I have my equals. So that's fine. That's dandy. But the rest is lost. So then for the right hand side, we go back up, then we loop. So we find double equals. We say, alright, the right hand side then is going to be parse comparison again. So we parse comparison. So we call that function again. That will parse term. It will find the less than or equal sign. So we'll parse term again. And we should return that as an expression. Where the expression is foo bar less than or equal to boo bar. Yeah. So I don't understand why it's not working here. Foobar, parsing this, it advances a token to here. Then we parse that token, that's fine. And we call, you know, the right hand side thing parse term again, which gives us nil here. So that's an expression. And then we advance. So now we've gone past the end of the tokens, which means we should just break. Yeah, so I don't understand what the problem is here. Let me try something. I'm going to print What's that less than or equal to? I'm gonna print the expression here, the right hand. Well, just the expression. So print line with all the bells and whistles expression. Okay. This branch never gets called, is what I'm seeing right now. There's nothing there, which is a bit weird. And if I were to do like greater, I assume it would be the exact same, right? Yeah, same thing. So somehow this is actually not getting called, which means this will return something else instead. And I have an idea why. Aha! The token needs to be advanced before. Yeah, I literally said that. I literally said that before. This needs to be parsed advanced here. And it's funny because I said that and then I forgot about it immediately, which is hilarious. So let me just fix that, and that should fix our issues. Where? Okay, now it works. There. You can see I have my 5 equals, or nil equals, and then we have less than or equals. So now it works. Okay. So now I just do the same thing for the others. I have a pattern that actually works. So now I shouldn't have any more issues implementing the rest. Okay. So then the next grammar rule is term, which is minus a plus, and then factor. So it goes in order of increasing precedence, right? So the lowest precedence is equality. The thing is, like, some of these could definitely be combined, but I suppose it's not too bad. Yeah, whatever. And like term for like addition and subtraction is like really vague. Like why is that the name, you know? But whatever. And yeah, sorry, unary has the highest. So same thing. Just copy this. Actually, I won't copy it because I'm gonna do it fully this time. So yeah, I'll copy this. Self.parse, whatever it wants it to be called, factor, and then going to loop, going to match on self.peak token, and if it's sum token asterisk, right? Then we self.advance token. We say let operator equal binary operator plus times. Sorry, I'm doing this wrong. Plus. Let right hand side is an expression equal self.parse factor again, and expression, we're modifying it, equals a binary operation right, or binary expression, not even. An expression binary, taking the operator, no, taking the previous one, the right hand side, because it's reverse pulse rotation, and then the operator. Is that right? I also have to box it. Okay. I'm writing out redundant code, and I could just copy paste it, but I want to make sure I'm like actually processing what I'm doing, just for the sake of learning. That's fine though. And then for the default case, it's just an empty we break. Okay, so now I'll copy this function. Hold on. This is invalid for some reason. What's wrong? We have some kind of syntax error that's causing this to not be highlighted, and I don't know what is wrong. Let me just try compiling here. Yeah, I'm worried there's no method called parse factor. Oh, I use an equal sign again. Oh, here. That's the mistake. Why does that change this color over here? Also, holy moly, look at that double arrow. That's crazy. But not as cool as this one. Sorry, not as cool as this one. Anyway, okay. Now I will just copy paste this. So parse factor, I believe calls parse unary, right? Yeah. So just replace factor with unary, and then asterisk times divide slash. Okay. And then parse unary, which might be the lowest, right? Yes. Now for unary, we don't actually have to parse the left side because it's the unary operator in this case. And the right side is just itself, or primary. So primary just returns a thing, yeah. I wonder why the right hand side is a unary thing. That is interesting. It calls itself recursively. Okay. So the operator is still there, but we have a minus and a bang. So the operator becomes unary operator, negative, unary operator, not. And then, ooh. This returns. Especially in unary, we don't have this. We just have the right hand side. Yeah, so I mean, this will only work for right-hand-sided, like prefix unary. There's also postfix unary, which would be considered potentially, but okay. So we just return it directly, which is interesting. And this is where I really take issue with Rust's, like, oh, if you have it here, then just, only use return for error statements. Well, then how about this? Like here I'm returning, but it's not an error, it's just a different kind of thing. Would be okay as well. So like what do you want me to do? Like have expression anyway, but then like fucking no, because it has to really return. I don't know, man. Return okay. No, return self dot parse primary. And it's not even clear like this is returning anymore. I don't know, man. Anyway, I mean, this is what it says. I'm just trying to like wrap my head around it. For these ones, it's recursive because the left side can be recursive. Here there is no left side, so we just recurse on ourselves. Sure. And then we have a function, finally, parse primary. Okay, where we match one of these. So it fits in, right? So we just match. We don't even loop, do we? No. So we just match on self dot peak token, and so on. So some token. Right. So we have literals and stuff, right? So here I actually need this again. And it can be a number, string, true, false, or nil. Or something in brackets. And brackets is where it gets a bit interesting, but anywho. So first one is number, which would be token number literal, n. Here we just do, we still have to advance the token. Although, it doesn't really matter, does it? No, I know it does, yeah. Advanced token, and return. Actually, can I just return straight up? Yeah. Like, just this. Okay. Expression literal number. Right? Yeah. I got string literal as well. Just do s actually instead of stir. Literal string. And bool. I think just true and false. I called it. That was a keyword. So if I have a keyword, yeah, he didn't differentiate it. But if I have a keyword k, then it's different. Hold on. Yellow. Yeah. Yeah. 1 second. Go quickly check my WhatsApp. Okay. Yeah. Okay. So it's just that, right? 62. Yeah. Okay. So are you booking out then? Yeah. Okay. That's sound. Well, so we'll get back then, and then I guess sleep first. Yeah. Okay. Wait, hold on. Is a ferry leaving at 4:30, or are we leaving at 4:30? Yeah. Okay. Okay. Yeah. Sick. Okay, packing then. 9:30. Yeah. I think I did it first, but yeah. Well, I'm gonna get dinner first, so maybe I'll be like a bit late, but otherwise, yeah. Is he? Right. Fair enough. All right. See you then. Awesome. Your boy's going to Ireland. Where was I? Literal. Sorry. Token. Keyword. Right? Yep. Keyword. True. Then literal boolean true. If it's false, then false. What else? Or nil. Keyword, I assume nil. Then that's just nil. Is that literal? Like, okay, dude, fuck. Okay. Literal, yeah, just nil. Nil is a literal. Okay, cool. So that should work. And then again, default case, we just return an error, right? But before that, okay, so now we have left paren. So paren start. So if you have a parentheses start, then this is special. So usually what you would do is you would call, just like without looking first of all, what you would do is you would call the top level function again, so parse expression, and then just parse that. And then if that reaches a right parentheses, then it just returns itself, and that's it. As an expression. Or I guess just this then. Like it should naturally reach a right parentheses. So that's fine. And then he returns a grouping, but I don't see why I need a grouping. I can just return an expression, right? Like as it is. I don't know why that would matter. So I'm going to leave out the grouping for now, but if I need to at some point, I'll obviously add it back. So yeah, I'll advance the token. I'll say let expression equals Parse expression, which could still fail. Then I consume it. So I say if self.peak token does not equal token paren end, then I violate my first error, which is return error, parse error, no unterminated parentheses. And I could hand it the expression, maybe. Probably not though. Yeah, fuck that. But yeah, I'm not using the. Okay, hold on. Here's the parse. Where's parse error? Here. Yeah, so this should be a struct, first of all. Public struct parse error. And this should be parse error type. So unterminated paren, right? And this struct, just like here with the tokenizer, wherever it is here, contains this. So it does drive debug. We have an error and the line number. So the thing is, I'm not really checking the line number right now, am I? Well, I guess I can. Yeah, I definitely can. So I'll have the. Hold on. Pub, yeah. So pub error is parse error type, and public line number is a usize. Okay, and this needs to derive debug, but also I need to write like a formatter for it. I'll do that later. And yeah, so it takes this, returns a error of parse error struct. Okay. I mean, I don't really need the return statement, do I? But returns this parse error, where I have error is parse error and line number is just get current line number. As a function, commas everywhere. Make sure this is self. By the way, just a little fun thing I learned today. One good reason to have trailing commas is not just for convenience, but also if you were to add another field. Like, let's say I didn't keep this because there's no point, right? But let's say I added another field here, right, called like some data, right? Let's say I did that. Then I would need to do this, right? I need to then add this here. Now, why is that a problem? If you were to look at the commits and like want to like merge commits and like review the commits, then adding another field here would end up affecting this line just by adding a comma. So then this line gets pulled into the commit even though it doesn't need to be. So that's another reason, which I think is pretty interesting. Anyway. So we get a parse error here. Yeah, I have to return because it's a statement. Otherwise, we just say okay, expression. But not before advancing the token again. Yeah, so get current line number. Need to define that. It'll be similar to this. I'm going to also not make it optional, so that it just assumes that you actually have the right fucking line number. And it would be a usize, remove this, line number. Okay, that's it. Cool, right? And that's it, right? And then it's just then we have the base case. So match against everything, which is another error. So this would be a parse error. Unrecognized token. Unrecognized. Or actually just invalid token. With line number, again, self.get current line number. Okay. Invalid token, we should pass in the token as well. So just some t, invalid token t. And that should cover that. So then, up here, we have invalid token. That's it. Okay. Kojo, Bailey. Okay, compile, I guess. Obviously I want to have some errors anyway, but I believe that's everything done. So 211 mismatched closing delimiter. I'm confused. What's wrong? It's saying that these are mismatched. Is it because I'm using just trying to return like this? Then should I return like this instead? I assume this should work. No, this should definitely work. Because it's the final statement, right? Yeah. Yeah, that's strange. It should work. If I do it in explicit return, does it have the same error? It does. That's weird. So it thinks these are mismatched. Even though my LSP seems to think it's fine. This one is also fine. This one is for this. Yeah, so what's wrong? I really don't understand. I don't understand. Let me ask Cloud. I don't understand the source of this error. Okay. I understand. There we go. Was that the only error? If so, not too shabby. Uh, 2, 3, 1. Wow. I'm still getting used to Rust syntax if you can't tell. Use size, mismatch type, 75. Line numbers are use size, no? Alright, it's a reference. No need, that's trivially copyable, so it should be fine. 211. Got a reference, wanted a thingy. I can't move it. The fuck? Dereference the borrow. Okay. Cannot find parse expression. Oh, right, it's just called parse. His one's called parse expression. Oh my god, bruh. What the fuck am I? I mean, I'll yeah, whatever. So I'll just do self.parse the other one, which is equality. Okay, line 232. It's an option. Okay, so it's just sum. Woo! One's a reference, one's not a reference. What? So I need to fucking partial EQ this shit? Okay, I guess. Debug partial EQ. How do I even do that? Surely I'd have I'd have input it myself, right? Partial EQ. And you do the same for all of them then? Dude, I don't have a reference! So I need to dereference it, right? Here. Cannot be dereferenced. So, so what do I do? Bro, that's what I'm matching the token. What? I want to match it like I would match on just like a fucking variable. No? Like, I don't want the address of it. I just want to match against it. What? Why can I not dereference it? Okay, so I can do if okay, let next token equals self dot peak token, and then if next token dot is sum and next token dot unwrap or just like none, I guess, actually is none, or okay, surely that works. Okay, remove these sums things. I'm so close. And then I need to dereference, right? Surely. Yes, okay, that works. Right. Associated item not found for this struct. What the fuck you on about? Line 235. Parse error type. Two three six. Line number unknown field. Line numer. Okay, that made a typo. Two four three. Expected token found option. Right. If I just do some token then, and then none would be another parse error, right? For unexpected end of file, or just end of file with a line number. Okay. Or just do fucking this, right? So line number, this, okay. Some t, I need to do reference t. Okay. Looks good. Well, it might not let me dereference t, to be fair, but we'll see. So I need to add a new thing here. But I should probably just clone the token then, right? Yeah. So I might need to do that. But anyway, unexpected, end of file. Let's have a look. 243. Sorry to be okay. What? Is it this? This be error. Immutable borrow to 11. What? Because of this? Cannot borrow self as immutable because it is also borrowed as immutable. I see. So what should I do then? Clone this. How about differencing .clone? No. I'm quite confused right now. Can I difference here instead? Hell no. What to do? What to do? What to do? Okay, so now the compiler's telling me to do something that doesn't fucking work. What's the actual problem? They're both borrowing. Can I just clone? Okay. I have this code, but the compiler doesn't like it because I'm using a immutable borrow before a mutable borrow. How can I fix this? Copy out, releasing the borrow. Okay. Okay. My brain is actually way too fried right now to understand this. But say we do, so say I do that then. Then for T, this doesn't have the copy trait, right? When do I implement copy versus clone? Copy's implicit. Clone is explicit. So do both. So do both, or just clone, or neither. Okay. So a token should probably be cloned then, right? So t.clone. Like this. Because there's no arrow syntax. So for token then, I need to derive copy and clone. This should be okay with just deriving clone though. I mean, just clone. No, so just copy. Both, I guess. Okay, fine. The should copy. Sorry, yeah, not this one. Because we've got heap allocation and stuff. Seems to work. Also, do I actually need these partial EQs? Yes. I don't get why I can match on it without partial EQ, but I can't do like a explicit equality check. I find that a bit strange. But I'm sure there's a good reason for it. Okay, move occurs because 216. Move occurs because S is string, right? So I'd have to do string dot clone preferably. Although, what if I do want to move it? It's behind a shared reference. I want to move string from the token to here. In C++, I do standard move. Here, I don't know what to do. Yeah. No copy trait. So please, could you move? And what if I want to, and what if n were a string? How would I move it? Okay, the issue is that it's a shared reference. Why is it shared? Why is it shared? Parse takes it as a... Yeah, parse expects it to be moved. So the parser is here. So it should just move it out of tokens. Or I could do like a string reference, I suppose. But no, because like I need it to be separate. Yeah, I don't know. Claude, help me. Returned own tokens from advanced token. I see. So I just need to like kind of fetch it directly. Okay, so how about I do let s equals self dot move current token. Like this. So then I have function move current token, which returns a token, not a reference, which just says self.token, self.position, dot token. And is it mutable? I guess it would be, right? Let me try without it, but I do suspect it would be mutable. Okay, seems to work. So now I just need to say let s equals the current token, which would be a token string literal s. Token does not implement the copy trait. Okay, so then do mutable. I don't want to clone! Fuck, dude. Okay. Issue with that. I don't want to clone. What if I don't care about what's left behind? Okay. Yeah, I don't care what's left behind at all, because this is passed through to the parser struct. So like nothing's being modified outside of the parser itself. I see. I don't really understand what's going on here. Why do I need to replace it with anything? Why can I not just move it? Like move the string pointer, like, and then like just leave the other one fucking whatever. But why do I need to leave a sentinel? What if I literally could not care less about the vector I'm moving from? I just want the performance. But if I remove it, then it fucks up everything else, right? But how does moving actually? But I thought moving a string was just pointer stuff. Why can't I just leave the value as is in the vector, and then just get another? Oh, cause is it Rust safety shenanigans? Probably is, to be fair. Oh my god, bro. This is actually one scenario where C++ is completely fine here and completely valid, whereas the Rust thingy is being a bit unreasonable. So it's saying I need to use an RC string or an arc string. Fuck it. For now, I'll just do a clone. It's a shame. Okay, what the fuck's going on here? In fact, just forget all of that. Yeah, just s.clone. Okay, so Kojo run. Okay. So it works, by the way. It says, let me just. Okay. Wait, where's the syntax tree? Oh, it has an error, I guess. Great. This one can't stack errors, I don't think. So we just do this. So E print line. Boom, 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 error. And so I need to have a fucking formatter for it. Where's parse error type? There it is. Yeah, so unterminated paren. We got unterminated parentheses. Unterminated. Invalid token. Just say invalid token T. I don't have a converter for that, so I'd use pretty formatting, whatever. And unexpected end of file. We just writes unexpected end of file. Okay. Then back to here. Parse error. Sorry, this should say token error, shouldn't it? They go parse error here. And parse error type here. Okay, that should work. Give it a try. Need to use standard FMT. What? Okay. Invalid token identifier foobar. Right. Let me just remove the fucking pretty format. Okay, nice. So yeah, we have it. I got an invalid token error, and I know you guys can't see it, but it's there because we don't support this yet. We need to support literal, so we'll do 6.4, and then we'll do like some string literal backslash hello. In fact, I'll make this one nil, and then actually I'll add another one for plus true. Okay. Invalid token less equals. Sick. Why? Why is that invalid? Let me try that with brackets. Yeah, so that doesn't do anything. But if I have an unclosed bracket, it'll find that error first. But let's say I have it like, I don't know, here. That won't work. Never mind. So yeah, for some reason it's saying that this is an error. It's an invalid token, less equals. For some reason I'm triggering this branch. But like, how am I getting that low? Oh. No, actually. What's the return if none of these are matched? Because it needs to return something, right? Wait, match number or string. It just returns a literal. No. I shouldn't get the fucking lesser equals like sign here though. It just shouldn't happen. Okay, let me try something a bit like more syntactically fucking valid. Because obviously this isn't valid, right? So let me try something else. Let's do like hello plus 5.3, 4 I guess, plus true. Does that work? Okay, that works. I get an AST with plus boolean plus number hello string. Okay, that's fine. But if I do like equals 2, well, that is valid. But what it does is, does 2 equal this entire right hand side, which is correct. Now if I use brackets instead, I get out of bounds. Okay, that's all good. Gotta fix that. And if I have an unclosed brace, same panic. Yeah, should have seen that one coming. If I get it unclosed, fuck, hold on. Why is it panicking? Yeah, I don't know. I'm gonna have to cut this stream short. It's been 4 hours straight, and I need to have dinner. So I'm going to leave now. It's already 9:22. But I will continue this at some point. I actually don't know when I can continue this, because I'm gonna be busy tomorrow, and for the next few days. But I will come back to this. Don't worry. But yeah, I'll figure this out. But in the meantime, let's leave it there for today. So yeah, subscribe to my channel for more content like this. Oh, so should I push my changes yet? Yeah, I probably should. Push and commit. Begin or finish most of Parser, although still has bugs. Yeah, I mean, version control just to be safe, really. Also, if it was like if it was like some production thing, I'd put it into a different branch or whatever. But I'm not gonna do that now. Anyway, that's it. I'll be back.